All right, I'm hitting you with some review here. I've got a parent function y equals x squared. It's a parabola. It's your favorite parent function. You know the parabola is your favorite. Name the transformation that each variable creates in the equation a times in parentheses, that's to the second power, so this is still a quadratic. That x is being raised to that power. What happens when I multiply the whole thing by an a? What happens when I multiply x times a b, or I subtract a c, or I add a d? So here's an example, just so you see what I was talking about. The a, the negative 2. If I just have an a, it'd be like I mean like 2x squared. What does that do? That is a vertical stretch. It makes the graph taller. Where numbers greater than 1 cause a stretch, but as you guys have found out, numbers between 0 and 1 fractions actually cause a shrink. So it's a vertical stretch or shrink depending on the number you're multiplying by. B, this number right here. Now you guys might not remember this because it doesn't happen that often. But whatever happens in the parentheses, you know that it says minus, but you go to the right. It's when you do stuff to x, it's backwards of what you think. Let me say that again. When you do stuff mathematically to x, it's backwards of what you think. So b being multiplied by x, multiplying is a stretch thing. This is a horizontal stretch. But you had to remember, I think in chapter 1, that it's backwards of what you think because it's in the parentheses. So numbers greater than 1 are actually causing a horizontal shrink. Where numbers between 0 and 1, the fractions, actually cause a horizontal stretch. It's backwards of what you think because it's inside the parentheses. So what do I mean by that? Y equals 2x in here being squared. Well, it seems like I'm multiplying, so I'm going to stretch something out. But inside the parentheses, it's a horizontal thing. So you guys know this, if I multiply, it's going to be 4x squared. It's going to be taller, isn't it? 4x squared. So what happens is it doesn't horizontally stretch the parabola. It horizontally shrinks the parabola, which makes it look taller. Right? Okay, C. C is right here. You guys are great at this one. That is a horizontal shift. It shifts or it moves left or right. Where a plus, because it's inside the parentheses, indicates you shift to the left, and a minus inside those parentheses, you shift to the right. Both of these things, let me put a little box right over here. Inside parentheses, where there's an x, is backwards of what you think. Now there's a reason for that. I don't want to get into it again. It's because, never mind. Just remember it that way and we're going to be okay. The D, this part right here, that is a vertical shift. A vertical shift up or down, where a plus indicates you're shifting up and a minus indicates that you're shifting down. Okay, we spent a couple of days on that stuff, and you've seen it in Algebra 1 and Algebra 2, so you should be pretty good at it, yes? Well, let's get back to this business here. Okay? Doesn't it make sense that for y equals a times the sine of x, just like a times x squared, a represents the amplitude because the amplitude is just a vertical stretch. Right? Example, describe the effect on the graph of a 3 when I put 3. Look at this. I'm going to put in parentheses. 3 is inside the parentheses times x now. That will create a horizontal shrink. Because it's times 3, it's going to be a multiplier, but because it's 3, it's backwards of what you think, so it's actually going to shrink. So you're going to take this sine graph and shrink it. It's going to make all those curves get closer together, isn't it? By a factor of 3, which will affect the period for sure. So how are we going to graph that? We're going to graph like a starting and a finishing place, but the finishing place will be closer, so that will make it shrink. It'll make the period 3 times shorter. And if the period was 2 pi, we're going to have a start at 0, but we're not going to finish at 2 pi. We're going to finish at 2 pi over 3, which is another number on your unit circle, by the way. Now describe the effect of the graph of a 1/2. If I have a 1/2 inside the parentheses, right? It's times the x, it's inside the parentheses. That will create a horizontal, backwards of what you think because it's inside the parentheses, stretch by a factor of 2, which will definitely affect the period. So what will happen there is instead of our normal sine function, it's going to get stretched out. It's going to take longer to go through that cycle. So it'll make the period 2 times longer. Okay, so here we go. Sketch the graph of 3, so I'm going all the way up to 3 and all the way down to 3, amplitude thing, of cosine of 1/2 x. So the period will be twice as long as it normally does. By the way, I could also write that as just x over 2. You guys might want to get used to that, right? Name the period, the amplitude, and then sketch it. Okay, you could sketch the original. It could help you out a lot. The period, it was 2 pi, right? The period, the cosine function was 2 pi. Let me just, real quick, I'll put the dots there. It says to hint, do a little sketch. There you go. There's a good starter. The period was 2 pi, but it's going to get multiplied by 2. So it's 2 pi times 2 is 4 pi. It's going to take me 4 pi units, not from here to here, but from here to here to complete that one cycle. So look, I'm going to go 3 pi and then 4 pi. That's how far it's going to take to get through one cycle. The amplitude is 3. I think that's pretty obvious for us. So it's not negative. That's nice. So I start up here at 0, 3. And I'm not going to finish this until I get all the way to 4 pi. So here's how you graph one of these. Graph the starting point, and then go all the way to the end and graph the finishing point. That's the secret to graphing these. Then what happens on a normal cosine graph? In the middle, you have a negative. You have a minimum. So what's the middle of 0 and 4 pi? 2 pi. Go down and put a point at negative 3. And then what else happens with a cosine function? There are zeros in between those. So in between this 0 and this 2 pi, there's going to be a 0 at pi. And in between, where am I at here? The middle is at 2 pi and 4 pi. It's going to be 3 pi. There will be a 0. So here you go. Here you go, kids. Here's the graph of 3 times the cosine of 1/2 x. It's 3 times as tall, and it's twice as wide. And so I could graph that same thing on the other side. Watch, I go to 2 pi, and I'm going to put a negative 3 pi, and I'm going to put a negative 4 pi. That's where this second one is going to finish. So it starts up here. It's not going to finish back up where it started until I get to negative 4 pi. At negative 2 pi, halfway between, there will be a negative 3. And then halfway between this 0 and this negative 2 pi is a 0 at pi, and there's a 0 at negative 3 pi. And here is another cycle of that graph. So I'm going to get out the blue marker and I'm going to finish that off. And I got to take a pause because I hear Mrs. Larson is feeding the dogs. And for God's sake, if you're not there when you feed the dogs, it could be mayhem and chaos. And we better get them outside so they can bark at the mailman. So I'll be back for the next page.